guys have basically learned all the stuff about rationals, or, at least I have showed it to you. Maybe you're still kind of learning it, which I understand. But now that you know all about asymptotes, slants, holes, intercepts, what we can do is we can kind of take all that information and we can essentially do it backwards, meaning we can write an equation. Okay, now this is a typical thing to do. We've actually done this with other things this year. Once you learn how to go forwards, now we're going to put her in reverse and we're going to go backwards. What you're going to find out is that to write a rational equation is really just an issue or a matter of trying to create the numerator and denominator. So that's why it's kind of backwards, because now you're creating it. And if you're going to create the numerator and denominator, you're going to create it being given the behavior. So what we're going to do is I think we're going to go through 4 of these. It's just 4. But we're going to see if we can take the behaviors and create the numerator and denominator. So what about this one? We've got a vertical asymptote. That's kind of good stuff. There's a horizontal asymptote. And then we've got this hole in the graph. If you want to take a moment and jot down any of those 3 specs, as maybe you're writing them down, you can always begin to think, how would I create the numerator and denominator? All right, well, I hope that the answer you give is that you would create that numerator and denominator much like you have spent the last week or so analyzing, where you try to come up with some type of expression that's going to give you a bad result. Okay, now, even though the hole is the listed last, one of the things I wanted you to get about the hole in the graph is it kind of overrules, it kind of takes precedence. So maybe we should start with the hole in the graph. I just want to start with it because I want you to realize that if there's going to be a hole in the graph at -2, then I need to have an x plus 2, but I need to have it repeating, which is half of the battle here. I have to make sure that it repeats in the numerator and denominator. Okay, now we had some people last period kind of like, how'd you know it was x plus 2? Well, we're just kind of thinking backwards, because basically -2, when plugged in there, is going to give you a 0 in the denominator. So we're trying to write an expression that's going to give us a 0. The vertical asymptote, it's got to catch your attention. It's been one of the big ideas this chapter. That's going to also contribute to the denominator. Basically, thinking backwards, you're going to need another expression. You're going to need x minus 3. And honestly, that's it. You don't have to think more. You don't have to change it. I guess I say you don't have to change it. You could change it if you want. If you really want to write it like this, let me be clear that you don't have to do that, but you can. What we do need to do, though, is we need to think about this horizontal asymptote. And kind of the deal with the horizontal asymptote is it should always come last, because the horizontal asymptote has to do with the comparison of the numerator and denominator. Now, if you compare the numerator with the denominator, it's actually kind of easy to compare it now. You can see that the degree, of course, was 1, but now you can see the degree is 2. By the way, the degree is still 2 over here. But since the degree is 1 compared to 2, now, are you getting to know those rules? That would always be y equals 0. So it's kind of like it's already giving us what we want. Now, if you're saying, what if it's not what I want? Well, you're going to see that in the next example. We might have to do a little adjusting. Okay. Each one of these problems kind of adds a new element. Even though we're adding a new element, I'm wondering if you can still create the elements that we talked about. So yes, I would jot down a couple of these phrases, but are you willing to try to create something? And then I'll help you figure out the new element. So we've got a pair of vertical asymptotes, 1 and -1. And we have a horizontal asymptote at 6. Are you willing to try to create? Are you starting with the denominator? It's where you should start. Okay, the denominator holds most of the expression. Okay, again, I don't want you to honestly overthink this. It's not much harder than just saying what expression is going to give me a 0 in the denominator. If you plug in 1, you get a 0 here. If you plug in -1, you get a 0 here. So that's good stuff. Now, if you would like, as we kind of set up here, you could kind of simplify it if you want to call it simplifying. And a lot of people, they like to kind of see it as x squared minus 1. If you want to do that, it's fine. What about the numerator? That's actually the new element here. It seems like there's nothing in the numerator. Okay, now we got to be careful. If you put something in the numerator, like if you put a 0 in the numerator, I don't know if you would have wanted to do that, but if you were thinking about that, you're just going to wipe out the whole fraction. So that's not a good idea. Geez, what can we put in the numerator? It seems like there's nothing there. Okay, well, the number one, it's funny, as soon as you put that there, you at least can see that there's a fraction. Okay, without anything there, it's really not a fraction. So did the number 1 mess up the denominator? Is it still going to give us a 0 down here? No, it's still good. What's the asymptote currently? What's the asymptote? Okay, now the answer to that is all you got to do is think of the degree. The degree is the highest exponent on x. Since there is no x, the degree is 0. Here the degree is 2. Okay, now listen, like we're good. Okay, like we haven't made a mistake, but right now the asymptote by the rule is at 0. By the rule, it's at 0. So we haven't made a mistake. We just need to fix it. Okay, now to fix it, what we could do is we could say, okay, the number 1, it gave us something to start with, but let's build a little bit more. Okay, let's build a little bit more. What about if you put the number 6 there? Okay, well, actually, if I put the number 6 there, the degree is still 0. Okay, but we're kind of building it. And what we're doing is we're building it closer. We're building it closer until we can get the degrees the way we want them. What if I put a 6x squared? Okay, it's kind of one of those you got to play along with me for a second. What if? Well, now my degrees are equal. And the rule says that I could use a over b. Now, a over b would be like 6 over 1. But you see how I did that? I build my numerator up until I got the degrees to be the same. And now that it's 6 over 1, I'm in business. Now, I could put a 6x squared over here just the same if you don't want that to look empty. Okay, 6x squared over x squared minus 1. There's another little secret about this problem. And the secret is you actually could get the right answer with a variety of options. I kind of like moved away from the number 1, but I just want to go back to it because if you use the number 1, the horizontal asymptote is at y equals 0. Remember, that's because the degree is less. Just want to be clear, it's at 0. Now, there was a time where we talked about you could take something and you could shift it. You see, if I'm at 0, but I want to be at 6, I could just shift 6. I could just put a plus 6. And that would also be a legitimate option. Again, 1 over x squared minus 1 plus 6. Okay, the horizontal asymptote, I don't want to say it's tricky, but it actually has options sometimes. This one, I didn't need any options. It was already right. This one, I could mess around with the degrees being equal. I could mess around with shifting. Okay, those are kind of your two options. All right, each one of these has a new element. Can you try to do, are you willing to try to do the ideas we've talked about, and I'll help you with the new element. Okay, obviously the slant is new. I realize you might be waiting for me to kind of show you, but you should be thinking about the vertical asymptote and the denominator. Okay, it's sometimes when we use the number 0, sometimes it gets tricky for us, but do you realize that that just means that a plain old x is going to get the job done? I don't need x plus 3. I don't need x minus this. If I'm going to have a 0, the number 0 in the denominator, then just a plain old x. Now, if you're wondering, do we have to do long division backwards? Well, at least you realize that slant asymptotes come from division, but it doesn't have to be long division backwards. I can just do regular division. I'm talking about this x just dividing into whatever might end up in this numerator. So we kind of have to think, okay, if I was going to divide by x, how could I end up with a slant at 3x plus or 3x minus 2? Okay, let me kind of help you to see that I can start with 3x minus 2. Now, I'm going to be honest with you, that's not going to be the final answer, but if you write that down, you're not going to erase it. So we're going to start with 3x minus 2. Remember what I said about dividing? Now it kind of seems like we have something to divide by or divide it into. Okay, the problem here is that if I divide these, they're just going to completely cancel. So it's another example that I need to build. I need to build it up. Literally, I have to build it up to a higher degree. Now, check it out. If I put some more x up here, I'm building up my numerator so that now when I divide it, it's going to divide back down to 3x minus 2. Okay, remember, a slant comes from dividing. Now, there's a small catch here, and that is that there's no remainder. This is a little mathematical, but the remainder is what is pushing the graph away from the slant. As your slanted line gets closer and closer to infinity, okay, it needs to get pushed away by something. That something honestly just needs to be any number. Any number. This is a little new, but if I put any number there for C, when I divide, that will be my remainder. The moral of the story is you need a remainder to get a slant. Okay, look, this is your final answer. I want to make sure there's no confusion. This fraction is your final answer. But if you divide it, which is the slant rule, if you divide it, you'll end up with what you want. Okay, now, do you realize that you could check any one of these? Maybe it doesn't get you super excited, but technically, if I'm writing equations, I could graph them and I could see if they look right. Okay, so what do we got here? Notice I'm typing in our equation, 3x squared minus 2x. Now, I put a number in for c. You honestly could put in any number you want and you would still be right. But if I put in the number 1, just kind of want you to see that we get both of our behaviors. We get a vertical asymptote. Okay, don't forget about the vertical asymptote. The graph shoots up, the graph shoots down. So that's good stuff. But we also get a slant. Maybe you can kind of see that there's a slant in here. We've seen a couple of these. But you can also graph your slant, 3x minus 2, and it fits in there nicely. Okay, so this would be a yes. This would be a success. I'm not going to make you do long division backwards. It would be a simple division like this. And remember, you just have to build the numerator. We build the numerator up 1 degree so that it can divide back down to my slant. All right, one more. Same kind of song and dance here. There's some new elements. I'm sorry, there's old elements, but there is one new element. Are you willing to try to make a numerator and a denominator? Don't worry about the third statement yet. You can still make a numerator and denominator for the first 2 statements. Okay, are you getting the main idea of vertical asymptote at -3? Okay, that has to be an x plus 3. That has to be an x plus 3 in the denominator. A hole in the graph. Now again, it's going to be at the number 0, so that means that a plain old x, now it has to repeat itself, but a plain old x is going to give us a hole. Okay, remember a hole comes from a repeated factor. Now, what is this passes through a point thing? Okay, well, to pass through a point would mean that if I plug in x and y, or I should say if I plug in 4x and y, it would have to work. It would have to satisfy the equation. What you might not know is that in order to do that, I need to have a shift number. And basically that shift number is there so that this graph can kind of move and pass through that point. The problem sort of boils down to trying to solve for C. Okay, now what you see me doing right here is I'm plugging in for x and y. That's pretty good stuff. You've done that more than once or twice this year. So I'm plugging in for x and y. But what I'm really going to need to do is make the letter C, or solve for the letter C, so that we can make this work. Okay, if you're willing to get into the numbers, you basically end up with -4 over -4 times -1. -4 times -1 is actually just positive 4. So it's not too bad. Once you get to that point, you can see that 7 equals negative 1 plus c, which is why c has to equal 8. Now, the final answer is not 8, but rather the final answer is the equation. I'm just going to cheat a little bit here and write the number 8. But the final answer is the whole equation, including the plus 8. In a moment, you guys are going to do a mini check. And remember, you're not going to do what I just did right here. Instead, what you're actually going to do is you're going to graph the equations. So what if I take this equation that we just created and graph it? And you're probably going to use Desmos, but if I type it in carefully. Okay, now one thing to note here is that there is a horizontal asymptote all the way up here at 8. Notice that we didn't really talk about that, but it just so happens that it has a horizontal at 8. But what I really want you to see is that if you go to the point negative 4, if you go to the point negative 4, okay, on my calculator, I do something called trace, but I basically get a success. I get it negative 4.7. So that's good. The other thing that you hopefully can see here is that there is an asymptote at negative 3. And then it's a little hard to see because the screen is kind of up high. I can kind of adjust the screen to make it a little easier for you guys to see. But there is a hole in the graph right here at 0. Okay, the reason I know that there's a hole there is because if I try to go to 0, I end up with a big old blank. And maybe you guys figured out on Desmos that if you trace to that spot, you actually get a hole to show up on the graph. Now, the practice sheet that was supposed to be what you worked on Friday, but I suppose you could have worked on it anytime.